Some nights the sky holds a kind of stillness that feels almost deliberate, as though the stars themselves are simply waiting patient and unhurried, scattered quietly above the rooftops and the bare branches and the long dark stretch of road outside your window. There is no rush in a sky like that. There never has been. If this feels like a good place to rest tonight, you are welcome to stay, just as you are, with nothing else required of you, nothing to solve, nothing to finish. Now, let's drift. Far beyond the edge of anything a human eye has ever truly seen, there are worlds where the sun does not move. Not once. It does not climb slowly over a hill in the morning, and it does not lower itself gently behind the horizon in the evening. It simply stays, hanging in the exact same place in the sky for years, for centuries, for the entire long and quiet lifetime of that strange distant ground. Tonight, in this slow and unhurried way, we're going to sit with a question that sounds almost impossible to imagine. What happens on a planet that never sees a sunrise? It helps maybe to start with something familiar first. Here on this world, the sunrise has always felt like a kind of agreement, something quietly made between the planet and the light, repeated every single day without complaint. The sky pales. The birds begin somewhere far off in that loose and scattered way they always do. And for a moment everything seems to remember itself again. We rarely think about why this happens. It simply does the way breathing simply does the way a heartbeat does not ask for permission. Earth turns once every 24 hours, a long, slow spin through empty space, and that single motion is the quiet reason morning ever arrives at all. Without it, there would be no sunrise to wait for. There would only be one long unbroken stretch of light, or one long unbroken stretch of dark, depending on which side of the world happened to be facing the sun when the spinning simply stopped. It seems that somewhere out there, for certain worlds, it already has. Researchers have found that many of the planets discovered orbiting close to small dim stars share this exact quality. One face turned forever toward the light. One face turned forever away from it. No sunrise, no sunset. No soft in-between hour where the sky changes colour and the day quietly lets go of itself. Just two halves of a single world locked in place, never trading positions, never taking turns, the way our own hemisphere does with its other half. A place suspended almost between two permanent states. It can be strange to picture. A noon that never ends, a midnight that never lifts, and somewhere between them presumably a long and narrow stretch of half-light that never moves, either caught in its own kind of stillness. What makes this even stranger in a quiet sort of way is how common these stars actually are. Scientists suggest that the small dim reddish stars capable of holding a world like this in such a tight locked orbit may make up the vast majority of all the stars scattered across our galaxy, far outnumbering bright stars like our own sun, which means in a sense that a sky without a sunrise might not be some rare cosmic accident tucked away in some forgotten corner of space. It might be closer to the ordinary condition of the universe. Our gentle rhythm of morning and evening, the one we never question, may actually be the unusual one. There is something almost tender in that thought if you let it settle for a moment. All of this turning, this rising and falling of light, this soft daily forgetting and remembering, might be a rare kind of gift rather than a guarantee. A world that gets to change its mind about the light again and again every single day. It may be that on one of those locked unmoving worlds, if a person could somehow stand on the narrow seam between the burning side and the frozen one, the sky would never shift above them at all. The same long shadows, the same low unmoving light caught somewhere between gold and grey. No clock would be needed there, not in the way we use one. No internal sense of morning arriving, no quiet animal knowledge that evening is coming on. Just one continuous moment stretched out across the whole of that world's existence, the same the day a person was born as the day they died. It is a strange kind of stillness to imagine. Not frightening exactly, just unfamiliar. The way silence can feel unfamiliar after a long time spent in noise. Studies indicate that even here on our own spinning world, the body keeps a very close, very private relationship with light and dark one. Most people never notice until it is somehow disturbed. A sense somewhere beneath conscious thought of when the day is beginning and when it is starting to close. We carry this rhythm so quietly that it rarely feels like a rhythm at all. It simply feels like being alive. And perhaps that is part of why a sunless world, or a sunrise-less one, feels so quietly unsettling to imagine. Not because it would be dangerous necessarily, but because it would ask the body to let go of something it has never had to question before. We are not going anywhere difficult tonight. There is no need to solve this or understand it fully or hold on to any of it too tightly. We are only going to wander gently the way you might wander about a house you will never visit in a town you will never see, under a sky that simply does not behave the way yours has always behaved. Before we drift any further into that hush, it might help to come back just for a moment to our own sky. The one outside your window right now, or the one you remember from some quieter night. Because the way it moves, the way light and dark take their slow, patient turns across it is not as simple or as inevitable as it has always seemed. It begins in a sense with something most people never think to ask about. Why does the sun move across the sky at all? Not why it rises in the east or why it sets in the west. Those are simple enough to picture once you know to look for them, but why it moves in the first place? Why morning ever arrives instead of staying exactly where it was the night before? The truth is something close to motion without movement. The sun, for all its brightness, mostly sits still in relation to us. It is the earth that moves spinning quietly on its own axis, a slow and steady turning that has been going on for longer than there has been anyone here to notice it. One full turn roughly every 24 hours carries you through morning, through afternoon, through the soft fading light of evening, and finally into whatever kind of night you happen to be having. The sunrise was never really the sun's doing at all. It has always been ours. A quiet gift of spinning. It seems that this single motion, so easy to take for granted, was not always this gentle or this steady. Researchers have found that billions of years ago, in the very early life of this planet, a day did not last 24 hours at all. It lasted closer to 6. The Earth spun far faster, then a blur of a world compared to the one we know now, with mornings arriving again and again, in a tight, breathless rhythm that would feel almost frantic if any of us had been there to feel it. There was no slow unfolding of light back then, no long afternoon to sink into, just a quick repeating flicker of day and night, over and over, like a pulse settling into a body that had not yet learned how to rest. What we understand so far suggests that something changed that rhythm slowly over an enormous stretch of time, and the thing responsible quietly, patiently was the moon. There is something almost tender in this part of the story if you let yourself sit with it. The moon, hanging there in the dark beside us, has spent billions of years gently pulling at the earth, tugging at its oceans, dragging at its very shape just slightly with each long, slow orbit. That pull created what scientists call tidal friction, a kind of soft, continuous drag between the two worlds. And little by little, turn by turn, that drag has been slowing the Earth's spin down. Not suddenly. Not in any way a person could ever notice in one lifetime. But steadily, the way a hand resting gently on a spinning wheel will eventually bring it to a calmer pace without ever needing to grip it tightly. Today, the days lengthen by only a few milliseconds every century, an amount of time so small it barely seems to exist at all, And yet, stretched out across the full age of this planet, it adds up to the difference between a 6-hour day and the 24-hour one we now move through without a second thought. The brain tends to register only the present rhythm, the one it already knows, the one it has grown around. It rarely senses the immense slow history sitting quietly underneath it. There is something gentle in imagining the moon as a kind of companion in that history. Not a dramatic force, not some sudden intervention, but a quiet, steady presence nudging this spinning world towards something calmer, something more livable, one almost imperceptible moment at a time. A 6-hour day might have made very little room for anything to settle or grow or rest. The long unhurried day we live inside, now evidence suggests, may be part of what made it possible for slower, more patient forms of life to exist here at all. Trees that take decades to grow tall, bodies that need 8 uninterrupted hours of stillness simply to feel restored. None of that fits easily into a 6-hour spin. It may be that the version of Earth most suited to gentleness was not the original one. It was the one that slowed down enough to allow for it. There is another quiet detail tucked inside this same story, one that rarely gets mentioned. The reason Earth tilts the way it does, leaning at that familiar angle, as it travels around the sun, giving us our seasons, our long summer evenings and our early winter darknesses, may also trace back to the same distant event that created the moon in the first place. Scientists are still exploring the exact details, but one widely held idea suggests that very early in Earth's history, an object roughly the size of another small planet collided with it, a slow, ancient impact that reshaped the young world entirely. From the debris of that collision, the moon is thought to have formed, and from that same disruption, Earth may have been left tilted on its axis rather than standing perfectly upright. It is a strange thing to consider, that the seasons, the long golden light of late summer evenings, the early dark of December afternoons, might trace their origin back to a single ancient collision so long ago that nothing remains of it now, except an angle and a moon and a rhythm that has held steady ever since. Psychologists often note that humans form a deep, almost wordless attachment to rhythm long before they ever understand the reasons behind it. A child does not need to know anything about axial tilt or tidal friction to feel the particular hush of a winter evening arriving early, or the loose golden stretch of a summer night that refuses to end. The body simply learns the pattern season after season, year after year, and begins to trust it. Spring will lighten, autumn will dim, morning, however, slowly will always come. Perhaps that trust is part of why the picture of a sunless world, or a world with no sunrise at all, can feel quietly unsettling, even from a great and harmless distance. Not because anything is wrong with it, only because it asks us to imagine letting go of a rhythm we never had to choose, the same way we never chose to breathe or to need rest, or to find comfort in a particular slant of evening light. This rhythm we live inside is not universal even here at home. The mind quietly registers light and dark differently depending on where a person happens to be standing on this slowly turning planet. Closer to the equator, day and night divide themselves almost evenly all year round, a steady back and forth that barely shifts no matter the season. But farther north or farther south, that balance grows more uneven. In some places, summer holds on to its light long past midnight, the sky never quite willing to go fully dark. And in winter, in those same places, the sun may barely lift itself above the horizon at all, offering only a few pale hours of grey light before retreating again. There are towns tucked into the far edges of the world where for weeks at a time the sun never sets, and others half a year later where for weeks at a time it never quite rises either. Not because anything has gone wrong with the sky, only because of the angle, the tilt, the particular way this spinning world leans toward or away from its star throughout the long year. It seems that even here on the most familiar planet any of us will ever know, there are places that brush up against something close to what we've been imagining all along. A sky that holds its light or withholds it for far longer than feels ordinary. A rhythm stretched thin almost to its breaking point, and yet somehow still a rhythm, still livable, still in its own quiet way home. Maybe that is worth sitting with for a moment, that even our own gentle, predictable world contains small pockets of strangeness, places where the line between day and night blurs and lingers in ways most of us will never personally feel. And maybe somewhere out past all of this, past the moon, past the tilt, past the long, slow turning of our own particular spin, there is a kind of edge waiting, a narrow, quiet seam between two permanent worlds, where light and dark do not take turns at all, but simply sit side by side forever still. There is a particular kind of stillness that settles over certain places on this planet even now, even with the spinning. We just spoke of the turning that never quite stops. Polar regions hold a faint trace of what we've been imagining tonight. Long stretches where the light barely changes, where the sun moves only a little along the horizon, for weeks at a time instead of rising and falling, the way it does almost everywhere else. It is not the same as a world locked entirely in place, but it is close enough perhaps to offer a small doorway into that idea. A hint of stillness borrowed from somewhere closer to home. Beyond that doorway, though, lies something far more complete. Astronomers have given a quiet name to the worlds we touched on earlier, the ones where one face never turns away from its star. They call this condition tidal locking, and it is not some rare exception scattered loosely across the galaxy. It is in its own way a kind of common fate, a gravitational pull patient and unrelenting, slowly stilling the spin of a smaller body until it stops turning relative to the thing it orbits. The moon above us, in fact, already lives this way. It shows us only one face, has always shown us only one face, the same pale features looking down through every century of human memory. We rarely think of the moon as locked in place. We simply think of it as the moon present and familiar, never once considering that this is what stillness actually looks like. Researchers have found that this same quiet locking happens far more easily and far more completely around small dim stars, the kind glowing faintly red rather than blazing white or yellow. A planet has to sit very close to a star like that in order to stay warm enough for liquid water, close enough that the star's gravity reaches across the gap and slowly stills the planet's spin entirely. Not over years, not over centuries, over spans of time so long they barely resemble time at all, the way geological ages do not resemble an afternoon. And once that stillness sets in, it tends to stay. The locking, once complete, rarely lets go again. One such place sits just over 4 light years from where you are right now, orbiting a star called Proxima Centauri. The planet is simply named Proxima Centauri, a small rocky world circling so closely, so tightly, that its entire year, its full journey around its star, takes only a handful of days. It seems that a world spinning that close to its star has little choice but to fall into this locked rhythm. One side warmed endlessly, one side left in permanent shadow, and somewhere between them that same narrow seam we wondered about earlier, neither fully lit nor fully dark, simply existing in its own quiet in between. There is something gentle in imagining a place so close, astronomically speaking, and yet so entirely unreachable. 4 light years sounds small when spoken aloud, smaller than it actually is. But the light leaving that star tonight, the very light that might be touching that planet's frozen locked surface at this exact moment, will not reach our own sky for years yet to come. A kind of delay so vast it stops meaning very much to a human mind, the way some distances are easier simply to feel than to calculate. Further out, much further, there is another place worth sitting with for a moment. A small dim star named Trappist, one discovered to be holding not one locked world, but several gathered closely around it, like quiet companions keeping watch over the same small fire. Several of these worlds are thought to be tidally locked as well, each one offering its star a single unchanging face. What we understand so far suggests that a person standing on the day side of one of these planets might look up and see their sun appear strangely large in the sky, fixed in one place forever, never climbing, never setting, simply present the way a lamp left on in another room is present whether or not anyone walks in to notice it. It may be that somewhere among those tightly clustered worlds, the narrow band between light and dark holds something we would recognize as weather. Not the dramatic kind, not storms in the way we picture them, but a slow, steady exchange of warmth and cold, moving gently across the seam where the two halves of the planet meet. Scientists are still exploring exactly what that exchange might look like, modelling the slow churn of imagined atmospheres pulled endlessly between a furnace on one side and a deep freeze on the other. The picture remains unfinished edges, still soft the way an idea feels before it has been fully thought all the way through. What stays with me most thinking about these places is not the heat or the cold or even the strangeness of a sun that never moves. It is the line itself, the seam, the place neither one thing nor the other, neither day nor night, simply holding its position between two extremes that never reach across to touch each other. There is something quietly familiar in that image, even here, even now, in a body resting in an ordinary bed in an ordinary room. We spend so much of our lives standing in exactly that kind of seam without ever naming it. Not fully awake, not fully asleep, not entirely certain, not entirely lost. Some part of the mind seems to prefer that narrow, unresolved space, the same way certain forms of distant life, if they exist at all, out there might prefer the gentle in-between light of a planet's eternal dusk to either of its two extremes. It is worth wondering gently why that might be. Why a creature or a mind or even a whole imagined ecosystem clinging to a thin strip of habitable ground between fire and ice might find more safety in the in-between than in either certainty on either side. And what researchers have started to notice in places far closer to home than any distant star is something the body seems to have understood quietly all along, long before anyone put a name to it. The body, it turns out, keeps better count of light and dark than the conscious mind ever does. Not through clocks, not through calendars, but through something quieter, running just beneath ordinary awareness, the way a river keeps moving long after you've stopped watching it. We will come back to that thread gently a little further along. For now it helps to follow it back outward, out past the edge of this room, out past the edge of this planet entirely, toward the place where light never wavers at all. Picture for a moment standing on the side of a locked world that always faces its star. Not at sunrise, because there is no sunrise there. Just standing simply beneath the sky, where the light has never once changed since the moment that ground first cooled into solid rock. Researchers who study these kinds of worlds often begin by imagining a single point directly beneath the star, a place astronomers quietly call the substellar point, the spot where the star sits motionless at the very peak of the sky, forever holding its position like a lamp bolted permanently to the ceiling of the world. It seems that this single point becomes the hottest place anywhere on a planet like that. Without the gentle daily relief of a sunset, without the slow cooling hours that even the harshest deserts on this world still receive each night, the heat simply gathers there and stays, Climate models built to study these distant worlds suggest that depending on how close a planet sits to its star, that substellar point could reach temperatures hot enough to keep rock in a slow molten state, a small circle of liquid stone sitting permanently beneath an unmoving sun. Around it, the heat would fade gradually outward in soft concentric rings. The warmth spreads outward from a hearth into a cold room, weaker and weaker, the farther it travels from the source. There is something strange in picturing weather that never changes by the hour the way it does here. The way clouds drift in and shift the light. The way a breeze rises in the evening, almost as if remembering something. On a tidally locked world, none of that quiet daily variation exists. The same intensity, the same angle of light every hour, every year, every age. What we understand so far suggests that an atmosphere sitting under those conditions would behave less like our shifting moody skies and more like a single fixed pattern, repeating itself endlessly, a song stuck gently on the same few notes. And the winds, if such a planet holds onto an atmosphere at all, are thought to move with a force that has little equivalent here. Atmospheric scientists running simulations of these locked worlds have found that the dramatic difference in temperature between the blazing day side and the frozen night side could drive winds reaching speeds far beyond anything that touches this planet's surface. Gusts strong enough in some models to circle the entire globe in only a matter of days, not storms in the way we picture storms with thunder and sudden fury. Something steadier than that. A vast continuous exhale pulled endlessly from the boiling centre of the dayside toward the frozen hush of the night, never resting. Never building toward anything, simply moving the way breath moves in and out of a sleeping chest without any awareness of itself. It may be that an atmosphere thin enough or a star active enough would not survive this arrangement for very long at all. Small dim stars, the very ones most likely to hold tidally locked worlds in their orbit, also tend to be restless in their youth, prone to sudden flares of radiation far more frequent and far more intense than anything our own gentle sun produces. Evidence suggests that a young planet sitting that close to a star like that might have its atmosphere slowly stripped away over millions of years, thinned out particle by particle, carried off into space, until very little is left to hold in any warmth at all. A bare, exposed face forever turned toward a star that helped shape it, and may have also in some quiet way unmade parts of it. It is not a hopeless picture, though, even with all of that considered. Some of the same models suggest that an ocean, if one exists somewhere on a world like this, could behave almost like a slow conveyor belt of its own gathering heat from beneath the unmoving star and carrying it gradually around the planet's curve, the way warm currents move quietly through our own oceans, unseen from the surface doing their patient work. A planet that cannot rely on rotation to spread its warmth evenly might still find a kind of balance through water, instead a different sort of rhythm, slower, steadier, carried not by spinning but by simple persistent motion. There is something almost touching in that idea if you sit with it for a while. A world locked in permanent stillness on the outside, and yet somewhere beneath its surface still finding a way to move, still finding a way to carry warmth from one place to another, even without the comfort of taking turns, even without ever once looking away from the thing that gives it light. We rarely think of stillness and motion as needing each other, but maybe they do more often than not. A planet that cannot turn its face away might still turn its water. A person who cannot quiet a racing mind might still find rest in the slow, steady motion of breath instead, in and out, asking for nothing more than to keep going gently. Astronomers studying the light from these distant worlds, the faint signatures captured in starlight passing through whatever thin atmosphere might remain, have started to notice patterns that hint at exactly this kind of imbalance and compensation working together. Not proof, not yet. Only soft suggestions gathered patiently from impossibly small amounts of light stretched across unimaginable distances, the way a half-remembered scent can suggest an entire room without ever fully revealing it. It is worth pausing here just for a moment in this image of a world held forever at noon, its single unmoving star pouring the same unchanging light onto the same unchanging ground day after day that never technically becomes a day at all. There is no relief built into a place like that, no evening to soften it, and yet somehow scientists studying these worlds keep finding small signs of balance hidden inside the imbalance itself. Quiet workarounds the planet seems to have found on its own without ever needing anyone to notice. There is another half to this story, though, lying just on the other side of that same locked world, a place that has never once felt warmth at all and carries its own kind of quiet entirely. On the far side of that same locked world, past the boiling stillness of permanent noon, lies a kind of dark most of us have never had reason to imagine. Not the soft dark of an ordinary night, the kind that lifts after a handful of hours and lets the morning back in. A dark that has simply always been there and always will be, stretching back farther than any memory the planet could ever hold, and forward presumably just as far. Astronomers who study these worlds give this place a name almost as plain as the one given to its opposite. If the point directly beneath the star is called the substellar point, then the point on the far side, the one facing only empty space, only the thin scatter of distant starlight, is called the antistellar point. The coldest place a planet like this could possibly hold. No star has ever warmed it. No star ever will. It seems strange to imagine a single spot defined entirely by something it has never experienced, but perhaps that is simply what permanent night is, an absence given shape. Researchers modelling these conditions have found that without the periodic relief of daylight, without the planet's surface ever facing toward warmth, even briefly, temperatures on a night side like this could fall low enough to do something that sounds at first almost impossible. The air itself might begin to freeze. It helps maybe to slow down on that thought for a moment. Here on this world we think of air as something untouchable, something that simply surrounds us, formless, weightless, always present in the same quiet way. But gases behave differently as temperatures drop low enough, and on a permanently dark, permanently cold side of a locked planet, certain atmospheric gases, nitrogen among them, are thought to reach a point where they stop behaving like air entirely. Climate scientists studying these extreme environments suggest that under the right conditions that gas could condense directly out of the sky and fall slowly, silently as something closer to snow. Not water snow, something stranger. Frozen atmosphere drifting downward in the endless dark, settling soundlessly onto frozen ground, layer over layer over layer, with no morning ever arriving to melt it back into the sky again. It seems that worlds far closer to home offer small true glimpses of this. Out at the edge of our own solar system, distant icy bodies are known to hold seasons so long and nights so extended that frozen nitrogen genuinely does blanket their surface for years at a time, only thinning again when their slow eccentric orbit eventually brings them nearer to the sun. A tidally locked world simply takes that same idea and removes the eventually. The night never ends. The snow, if it falls there at all, may never stop falling. There is something quietly heavy in picturing that. An entire hemisphere slowly losing its breath to the cold, the sky itself drifting downward and settling into stillness on the ground. Evidence suggests that in the most extreme versions of this process, an atmosphere thin enough or a star dim enough could allow nearly all the air on the night side to freeze out completely, over time pulled there and trapped, while the day side, blazing and restless, keeps whatever atmosphere remains stirred into constant motion. Scientists sometimes refer to this danger as atmospheric collapse, a slow, one-directional drift, where the sky essentially relocates itself, gathering more and more thickly on the cold side until very little is left anywhere else. It is not a small thing, an atmosphere disappearing like that, and yet there is something almost gentle in how quietly it would happen. No explosion, no sudden catastrophe, just an enormous hush settling in slowly over uncountable years, the kind of ending that happens so gradually it barely qualifies as an ending at all. More like a long-drawn breath held and held and held, with no clear moment where anyone could say, here, this is when it finished. What we understand so far suggests that not every locked world would lose its sky this completely, though. Much depends on small, quiet variables, how thick the original atmosphere was, how strong the planet's own internal warmth still runs beneath its crust, whether winds on the day side manage to push enough heat across to the frozen half before it has the chance to settle. Some models picture this constant restless circulation, this trade of warmth from one face to the other, as the very thing standing between a planet keeping its sky and a planet slowly losing it to its own permanent night. A precarious kind of balance held in place by motion that never gets to rest. There is a strange comfort, in a way, in this idea of something staying alive specifically because it keeps moving. It does not feel so distant from certain quiet truths about a body or a mind, both of which seem to falter, most not from effort but from too much stillness held too long in the wrong direction. The visible surface of a frozen lightless hemisphere like this, if it could somehow be seen rather than only modelled, is imagined by some researchers as something closer to glass than to ordinary ice. Frozen gases layered and compacted over enormous stretches of time are thought to take on smoother, more reflective surfaces than the rough, familiar ice found here on Earth. A great pale field catching whatever faint starlight reaches it from the rest of the galaxy, glowing very softly, very distantly, the way a single candle might glow through a thick pane of frosted glass in another room. Not bright, just present. A small quiet sign that the dark even here is not entirely without light of its own. It may be that this faint glow is not even the strangest kind of a light a planet like this could hold. Some of the locked worlds we've spoken of orbit close enough to their dim, restless stars that they sit fully exposed to whatever charged particles those stars send streaming outward. Researchers studying our own planet's relationship with the Sun already understand a softer version of this phenomenon quite well. We call it an aurora, hear those slow curtains of green and violet light that occasionally drift across our own night sky, near the poles born from solar particles meeting our planet's magnetic field high above the ground. On a tidally locked world, especially one circling an active little star, that same interaction is thought to potentially happen far more often and far more intensely, painting the permanent dark with light. It never receives from the sun at all, only borrows briefly from the storm of particles drifting past it. There is something tender in that image if you let yourself sit with it. A side of the planet that has never once seen daylight and yet still finds itself touched now and then by colour. Not warmth, just colour, brief and shifting, moving silently across a sky that otherwise asks for nothing and expects nothing in return. It seems that even total darkness, the kind with no foreseeable end, still tends to hold small interruptions of its own. A planet's atmosphere thinning out as it freezes does not necessarily mean it goes quietly without remainder. There are still these soft shimmers passing overhead sometimes, still these slow ribbons of light drifting across a sky that has never known a sunrise and never will. Perhaps total absence in nature is rarer than it first appears, Even the coldest, most unchanging places we can imagine still seem to hold a little room left over for something gentle to slip through. It is worth noticing too how naturally the mind reaches for comfort even inside an idea built almost entirely from cold and stillness. We're not really afraid of the dark itself most of the time. We're afraid of the dark holding nothing at all. And so even here, speaking softly about frozen air and silent glaciers of nitrogen, settling endlessly onto a hemisphere with no morning waiting at the end of it, something in us quietly looks for the aurora, the shimmer, the small proof that even permanent night still has its own kind of breath moving through it. There is a third place on a world like this, though neither blazing nor frozen, neither relentless light nor endless dark. A narrow seam where these two extremes meet, but never quite cross, holding its own position, the way a held breath holds itself just before it is finally released. On the locked world, we've been imagining together the place where one face burns and the other freezes into stillness. There is one more region left to consider, a narrow band running like a long quiet ring around the entire planet, exactly where the blazing half meets the frozen one. Astronomers who study these worlds call it the terminator zone, and it might be the only place on the entire surface where conditions ever settle into something resembling balance. It helps maybe to picture it slowly, not a sharp line the way a shadow falls suddenly across a wall when a light switch is off. Something softer than that, a gradual fading mile after mile from blinding light into deepening shade, the way dusk moves across this world in the minutes after the sun has gone, except here it never finishes moving. It simply holds its position forever, caught in that long in-between hour, neither one thing nor the other. Researchers modelling the climates of these planets have found something almost tender hidden inside that arrangement. While the day side bakes and the night side freezes, the terminator zone often settles into temperatures that in certain models fall close enough to what living things here would recognize as mild. Not hot, not frozen. Simply temperate the way a spring afternoon feels temperate, suspended permanently in that single comfortable register, neither needing a blanket nor needing shade. What makes this even more interesting in a quiet way is something atmospheric scientists noticed while running simulations of how clouds might behave on a world like this. It seems that directly above the hottest point on the day side, where the star sits forever fixed at the peak of the sky, thick clouds may form and simply stay there locked in place above the same patch of ground for the entire life of the planet. The brightest part of the world may end up paradoxically partially hidden beneath its own permanent weather. Researchers studying this effect have suggested that these unmoving clouds could act almost like a natural shade, reflecting a portion of the star's light back into space before it ever reaches the ground, quietly cooling a place that might otherwise become far too hostile to hold any kind of balance at all. There is something gentle in that image, a planet seemingly protecting its own hottest wound. With a soft covering it grew entirely on its own, without anyone asking it to. Some of the scientists who study these worlds have given a particular kind of tidally locked planet an almost affectionate name, one that has nothing to do with technical jargon at all. They call certain ocean-covered locked worlds eyeball planets. It is worth sitting with that image for a moment because it is a strange and oddly beautiful way to picture an entire world. At the very centre of the day side, where the heat is greatest, a wide stretch of open liquid ocean is imagined to remain kept warm and unfrozen by the unmoving star above it. Around this, like an iris circling a pupil, lies a thinner ring of partially frozen sea, neither fully solid nor fully liquid. And further out, still wrapping the entire dark hemisphere, an outer ring of deep permanent ice, vast and pale and still. Seen from a distance, if anyone could ever see it directly, a planet shaped like this might genuinely resemble something close to an eye. a great slow, unblinking eye held open forever toward the same small dim star watching it, the way nothing here on our own busy rotating world ever could, simply because we are always turning away to look at something else. It is the thin watery seam between the open ocean and the deep ice, that narrow ring resembling an iris, that researchers suspect could matter most of all. It seems that within this single strip conditions might remain mild and stable for unimaginable stretches of time, long enough, some scientists propose, for the slow chemistry that leads toward life to have every opportunity it might need. Not a guarantee, only a possibility gently raised and still being explored, but a possibility worth holding on to for a moment, the idea of an entire potential biosphere fitting neatly inside one narrow twilight-coloured ring circling a frozen eye in the dark. There are quieter parallels to this kind of narrow twilight habitat much closer to home if we let ourselves notice them. Marine biologists studying our own oceans have long given a name to a particular depth, far below the bright sunlit surface waters and far above the absolute blackness of the deep sea floor. They call it the twilight zone, a band of ocean where only the faintest hint of sunlight ever penetrates, where the water holds a permanent dim blue-grey hush regardless of the hour above. Studies indicate that an extraordinary number of species make their home specifically within this narrow band, neither needing the brightness above nor able to survive the crushing dark below, simply suited completely and quietly to this one particular shade of in-between. It may be that this pattern life gathering most thickly not at the extremes but somewhere in the soft margin between them is closer to a universal tendency than a coincidence. The edge of a forest holds more variety than its deepest, darkest centre. The shoreline holds more life than either the open ocean or the dry land sitting just beyond it. Even within our own bodies, some of the most active, most essential processes happen, not in moments of total stillness or total exertion, but somewhere quietly between the two. There is a soft kind of pattern here repeating itself at every scale, from oceans to planets, to something as small and personal as a single resting body. The edges, it seems, are where things tend to gather. Plant biologists thinking about what life might actually look like if it ever did take hold along a tidally locked planet's terminator ring have wondered about something particular to that environment. Here on this spinning world, plants have evolved to track a sun that moves steadily across the sky throughout each day, some species turning their leaves slowly to follow it, a quiet motion called phototropism, present in nearly every green and growing thing around us. On a locked world, though, the star never moves at all. It seems that a plant evolving under conditions like that would have no particular reason to develop that same daily turning. It could simply grow facing one fixed direction forever, the way a single sunflower might, if its sun had stopped its slow arc across the sky, permanently holding the flower's face gently in place, rather than asking it to follow anything at all. There is something quietly moving in that image. A plant that never has to search for the light. A plant that simply already knows completely and permanently exactly where to look. The light along this narrow ring, even on the warmer edge nearer the dayside, would likely arrive at a steep low angle, never directly overhead the way it can reach here at midday. Researchers studying the physics of these locked systems suggest that anything living within the terminator zone would experience something closer to a permanent gentle dusk, regardless of which direction it happened to be facing. Not darkness, just a soft, slanted, golden kind of light, the same hour repeating itself endlessly, neither brightening toward noon nor fading toward evening, simply staying. It is worth imagining for a moment what it might feel like to live somewhere lit permanently by that single unchanging hour. The hour just after the sun has begun to lower itself, when the light turns warm and a little golden, when the sharp edges of the day start to soften when everything quiets almost on its own. Most living things on this planet experience that hour only briefly a transition, rather than a destination gone again within minutes. On a world shaped like the one we've been imagining tonight, that single soft hour might not be a transition at all. It might simply be the entire condition of being alive there. One long continuous dusk held in place, asking nothing further of anything living inside it. There is a quieter layer to this, though, one that most people never consider when they first imagine a world without a sunrise. We've been speaking so far mostly about ground and light and ice and water, about the shape an unfamiliar planet might take from the outside. But there is another kind of terminator zone, a narrower, more private one that does not orbit a distant star at all. It lives instead in something much closer, somewhere just beneath the surface of a single ordinary resting human body. There is a quiet question worth sitting with for a moment now that we've spent so long imagining a planet without a sunrise. What would actually happen not to a planet but to a person if the sun simply stopped doing what it has always done? Not stopped existing, just stopped rising, stopped setting, stopped offering that long familiar signal the body has relied on since before there were bodies at all to rely on it. It turns out we do not have to imagine this entirely from nothing. A handful of people scattered across the last century have actually lived through some version of it, usually by choice, usually in the name of quiet scientific curiosity. In the 1960s, a French researcher named Michel Siffry spent more than 2 months living alone inside a cave deep beneath the Alps, far below any trace of daylight, with no clock, no calendar, no contact with the outside world at all. Researchers have found that what happened to his sense of time inside that darkness was strange in a very particular way. He did not lose track of day and night entirely. His body kept inventing them anyway on its own, cycling steadily between long stretches of wakefulness and long stretches of sleep, even with absolutely nothing from the world outside to prompt it. But the rhythm drifted. Slowly, gently, his days began stretching longer than 24 hours, sometimes by half an hour, sometimes closer to a full hour, until by the time he emerged he believed far fewer days had passed than actually had. It seems that the body left entirely without sunlight does not collapse into chaos. It does something quieter and stranger than that. It keeps its own kind of time anyway, faithfully, persistently, the way a heart keeps beating with no one in the room to remind it. The rhythm simply loosens its grip on precision, the way a song played from memory might drift slightly out of tempo over time, still recognizably the same melody, just no longer quite locked to the beat. Researchers studying the years following Siffry's experiment have found similar patterns in other isolation studies, since people living in deep caves in sealed laboratory chambers, entirely free of clocks or natural light in remote Arctic and Antarctic research stations during the long months when the sun simply never lifts above the horizon at all. Studies indicate that nearly everyone in these situations begins gradually to drift toward a sleep and wake cycle, slightly longer than the standard 24 hours, somewhere closer to 24 and a quarter on average, though the exact number varies gently from person to person. Scientists sometimes call this a free-running rhythm, free in the sense that it has been released from its usual anchor, running in the sense that it does not stop. It simply continues quietly on its own private schedule, no longer perfectly matched to the actual turning of the planet. There is something almost moving in that detail if you let it settle. The body does not need the sun to keep time, it only needs the sun to keep correcting it. It may be that this distinction matters more than it first appears. Without daylight's daily nudge gently resetting the body's internal rhythm each morning, that rhythm tends to slowly slide out of alignment, with the actual hours of the day stretching itself a little longer, a little later, again and again. The way a melody played slightly too slowly will, given enough repetitions, eventually fall completely out of step with the song everyone else is singing. Scientists refer to this daily nudge with a particular term calling daylight a Zeitgeber, a quiet borrowing from the German for time giver, something external that resets an internal rhythm that would otherwise simply drift along at its own slightly imperfect pace. A German researcher named Jürgen Aschoff ran some of the earliest and most thorough studies into this exact question, inviting volunteers to live for weeks at a time inside specially built underground bunkers, entirely isolated from sunlight clocks and any cue at all about the actual time of day. What we understand so far suggests that his findings echoed Cifra's solitary discovery almost exactly. Every volunteer kept their own steady rhythm. Every volunteer drifted slowly away from the 24-hour day. The rest of the world outside was still quietly keeping. Some stretched their days to 25 hours. A few more unusually found their rhythms drifting in stranger directions, entirely splitting their sleep into different patterns than the long, single stretch most of us are used to. Almost as though freed from daylight's quiet authority, the body felt permitted to reorganize itself in ways it might never have considered otherwise. It is worth pausing here gently to notice something tender hidden inside all of this. None of these participants deep in their caves or their underground bunkers fell apart. Their minds did not simply stop functioning without daylight to guide them. They adapted. Quietly, steadily, almost without effort, finding new rhythms suited to a world that had quietly removed one of its oldest and most reliable signals. There is a kind of resilience in that worth sitting with for a moment, the body's evident willingness to keep going, keep resting, keep waking, even when something as fundamental as a sunrise has been gently taken away. Some of the clearest evidence for how deeply light shapes this rhythm comes from research involving individuals who are completely blind with no perception of light at all, not even the soft, formless brightness some partially sighted people retain. Neuroscientists have observed that a significant number of these individuals experience exactly the same kind of free-running rhythm. We've been describing their internal clocks drifting slowly across the calendar precisely because the particular light-sensing cells responsible for resetting that rhythm each day receive no signal whatsoever to respond to. It seems that this particular function, the body's quiet daily recalibration towards sunlight, runs on its own, dedicated pathway separate even from ordinary visual sight. A person could in principle see nothing at all, and still somewhere deep inside retain the biological machinery built specifically to notice the sun. It simply has nothing left to notice in their case, and so the rhythm drifts onward gently uncorrected exactly the way it would for someone living entirely inside a planet's permanent night. There is something quietly profound in that detail. The body did not evolve only to see light. It evolved separately simply to register that light exists at all, a function so essential that biology built it its own private channel, distinct even from vision itself. Researchers studying populations living at extreme northern latitudes in towns and villages where the sun disappears below the horizon for weeks, at a stretch each winter, have found gentler everyday versions of this same pattern. Sleep tends to lengthen slightly during these dark months. Energy and mood often shift in small recognizable ways. Psychologists often note an increase in symptoms resembling seasonal depression during these long stretches without daylight, a quiet reminder that the body's relationship with the sun reaches well beyond simply telling time, touching something closer to emotional steadiness as well. And yet even Somewhere inside the human body, smaller than a grain of rice, sits a structure that has never once seen daylight directly, and yet seems to organize almost everything around the question of when light should be expected to arrive. Neuroscientists call it the suprachiasmatic nucleus, a small cluster of cells resting deep within the brain, just above the place where the two optic nerves cross paths on their way toward vision. It is worth sitting with the strangeness of that location for a moment. This tiny structure is positioned almost exactly where the signal for light first arrives, as though the body built its master clock deliberately close to the one sense most capable of telling it what time it actually is. Researchers have found that this small cluster of cells does something remarkable simply by existing. Removed entirely from the body and kept alive in a laboratory dish, disconnected from eyes, from skin, from any signal at all, these cells continue firing in a steady, repeating rhythm, rising and falling in activity roughly once every 24 hours, all on their own. Nothing is telling them to do this. No light reaches a dish in a laboratory drawer, and yet the rhythm persists anyway, quietly, faithfully, as though time itself were something written directly into the cells, rather than something they had to learn from outside. It seems that this single detail changes the entire way we might think about a body living somewhere without a sunrise. The rhythm is not something the sun gives us. It is something we already carry on our own, written somewhere deep in biology long before any of us were born. The sun's role then is something gentler than creation. It is closer to correction, a daily patient nudge keeping an already existing rhythm from drifting too far from where the actual world has turned to. This raises a quiet question worth letting settle slowly. If the rhythm already lives inside us untouched by light, what exactly is the sun correcting it toward? The answer researchers have arrived at involves a chain of signals so delicate it is almost difficult to picture. Light entering the eye, even with the eyes gently closed in dim conditions, is detected by certain specialized cells in the retina cells that evolutionary biologists have found are distinct from the rods and cones responsible for ordinary sight. These particular cells exist for one purpose, alone, simply to notice whether light is present, and to pass that single piece of information backward into the brain toward that same small ancient clock resting above the optic crossing. What we understand so far suggests that once this signal arrives, the suprachiasmatic nucleus quietly adjusts its own rhythm to match it, resetting itself by a few minutes each day, the way a slightly imprecise clock might be nudged gently back into alignment each morning by someone walking past and adjusting the hands. Left alone without that daily correction, the clock continues ticking. It simply drifts slowly the way we spoke of earlier, no longer perfectly matched to the spinning of the actual planet underneath it. From this small cluster of cells, a long, quiet chain of instructions spreads outward into the rest of the body. One of its clearest expressions involves a hormone called melatonin, produced by a small gland sitting deep within the brain, releasing itself gradually as darkness falls and quietly stepping back again as light returns. Researchers studying this hormone have found that its rise does not simply make a person feel sleepy in any direct, forceful way. It seems to function more like a signal flare than an order, a quiet announcement sent outward to nearly every system in the body that the dark portion of the day has now begun leaving each system to respond to that announcement in its own particular way. The mind quietly registers this signal in countless small adjustments most of us never consciously notice. Body temperature drops slightly, blood pressure eases, certain digestive processes slow their pace. None of this happens because the body has decided consciously that it is time to rest. It happens because thousands of individual cells throughout the body carry their own small, quiet copies of this same internal clock each one listening for the same chemical signal, each one adjusting its own behavior accordingly, the way a large orchestra without a single visible conductor might still stay remarkably together simply because every musician has learned to listen closely to the same quiet internal beat. It may be that this detail more than any other captures something true about how thoroughly time lives inside a body rather than outside it. We tend to imagine the sun as something that happens to us, a force acting from the outside in. But researchers studying these cellular clocks have found that nearly every organ holds a slightly independent version of this same rhythm. A liver that quietly anticipates when digestion will be needed, a heart that adjusts its resting rate slightly across the hour's skin cells that repair themselves more actively during specific windows of the night than during the day. The sun does not create these rhythms from nothing. It simply keeps an entire orchestra of small separate clocks playing in time with one another. This brings us back gently to that locked sunless planet we've spent so long imagining together tonight. If life were ever to take hold somewhere along its narrow twilight terminator zone, evolutionary biologists who study this question have wondered whether such life might still carry some version of an internal clock even without a true day and a true night to correct it against. It seems entirely possible. A rhythm, after all, does not strictly require an external cue to begin existing. It can be carried written somewhere in deep biology, the way our own suprachiasmatic nucleus carries its rhythm in a laboratory dish with absolutely nothing to keep it correct. A creature evolving along an endless unmoving dusk might simply keep its rhythm quietly to itself, never needing correction, because nothing around it ever changes enough to suggest a different time has arrived. There is something almost touching in that possibility, a form of life that never needs reminding what time it is, because the world around it never asks the question in the first place. It is worth turning back towards something closer to home now gently before we drift much further. Even here on this spinning rhythmic world, something curious happens to a person's internal clock. The moment external light disappears entirely, even briefly, even for a single quiet evening spent without screens or lamps. Researchers studying melatonin release have found that modern artificial light, especially the cooler, bluer wavelengths common in many devices, can delay this hormone's natural rise by an hour or more, quietly convincing the body that daylight persists longer than it actually does. In a strange, small way, this means that many people already live every single evening inside a softened version of that locked planet's endless terminator hour light, lingering artificially past the point where the body left alone would have already begun preparing itself gently for rest. It seems that simply allowing a room to dim naturally without resistance, without forcing anything, offers the body one of the clearest signals it can receive that the rhythm it has carried since long before any of us were born is finally permitted to continue exactly as it was designed to. There is a quieter idea sitting underneath all of this, one easy to miss amid the details of cells and hormones and small adjusting clocks scattered throughout the body. Each of these rhythms operates almost entirely outside conscious awareness. No one decides moment to lower their blood pressure as evening approaches, or to begin repairing skin cells more actively after midnight. These processes unfold quietly beneath conscious thought entirely, the body managing its own intricate patient choreography, without ever once asking permission from the part of the mind that imagines itself in charge. It may be that this is one of the gentlest truths buried inside tonight's long, slow, wandering through frozen planets and internal clocks alike. So much of what keeps a living thing steady happens far below the surface of awareness, quietly, faithfully, without applause, without acknowledgement, without ever needing to be noticed in order to keep doing its work. A planet's terminator zone holds its narrow balance without announcing itself. A cell deep in the brain keeps its rhythm without anyone watching. And a body resting now in an ordinary room continues this same quiet work tonight, unnoticed, unhurried, simply because it has always known how. The mind, it seems, has been keeping something still and patient all along, somewhere just beneath where thought usually wanders, and there is a little more of that quiet patient work still waiting gently to be noticed. Far beneath the surface of our own ocean, deeper than any sunlight has ever managed to reach, there are places where life has never once depended on a sunrise at all. Researchers exploring the deep-sea floor have found entire ecosystems clustered around narrow cracks in the Earth's crust called hydrothermal vents, where mineral-rich water heated by the planet's own internal warmth rises up through total darkness and somehow supports thriving communities of tube worms, blind crabs, pale shrimp, and countless smaller creatures that have spent their entire evolutionary history without ever needing to know what daylight feels like. It seems strange at first to imagine life flourishing in a place with no sun at all. Almost everything we tend to associate with living things, with growing things, traces itself back eventually to sunlight, to photosynthesis, to that one warm source, feeding nearly everything else in some indirect way. But these vent communities rely on something else entirely, a process called chemosynthesis, where certain bacteria convert chemicals rising from inside the Earth itself into usable energy, quietly building an entire food chain from the planet's own warmth rather than the star above it. A whole true ecosystem thriving permanently in conditions not so different from the eternal dark side of the locked worlds we have spent so long imagining tonight. What researchers have found particularly interesting about these communities is that many of their inhabitants still appear to keep some kind of rhythm even with no daylight ever reaching them at all. Marine biologists studying certain vent species have noticed patterns of activity that rise and fall with a regularity too consistent to be pure coincidence, though the cue behind it is not the sun. Some scientists suspect these rhythms may be tied instead to the gentle repeating pull of the tides far above them, or to subtle fluctuations in the vent's own geothermal activity, faint pulses rising up from deep within the Earth on something closer to their own private schedule. A rhythm, in other words, does not strictly require a sun to exist. It only requires something steady enough, something repeating enough for a living thing to quietly organize itself around. There is something worth sitting with in that idea for a moment. Even in the deepest, darkest, most sun-starved corner of our own planet, life has still found some pattern to hold on to. Not the pattern we expected, a different one entirely borrowed from warmth rising through rock instead of light falling from the sky, but a rhythm nonetheless present and persistent, the way a quiet drum beat can still keep a room moving together, even with the lights completely off. This raises a gentle question worth carrying upward out of the deep ocean and into something closer and more familiar. If a rhythm can be built from tides or from the patient pulse of geothermal warmth, what else besides sunlight might be capable of holding a body steady? Psychologists studying human sleep patterns have spent a great deal of time exploring exactly this question, and what they have found suggests something quietly moving about how thoroughly we are shaped not only by light, but by each other. Researchers studying circadian rhythms introduced a particular term decades ago to describe this idea, calling certain non-light cues social Zeitgebers, borrowing the same German phrase for time giver we spoke of earlier, only this time applied to something entirely human. Mealtimes shared with other people, the particular rhythm of a household waking and settling together, the quiet structure offered simply by being around another person who keeps a steady, predictable pattern of their own. Studies indicate that these social cues can meaningfully stabilize a person's internal clock, sometimes nearly as effectively as light itself, gently anchoring a rhythm that might otherwise begin to drift the way Michel Siffres did alone in his cave with nothing external left to correct him. It may be that this helps explain something researchers have observed in certain blind individuals whose eyes carry no light-sensing function, at all the same population we touched on earlier, whose internal clocks tend to drift freely without daylight's daily correction. Clinical studies have found that even among this group, a meaningful number manage to hold a steady 24-hour rhythm, regardless, not because any light reaches them, but because the structure of their daily lives, regular mealtimes, consistent social contact, a predictable rhythm of conversation and company, provides enough of its own quiet correction to keep the internal clock from drifting too far. Connection in these cases appears to do some of the same gentle work that sunlight does for the rest of us. There is something tender in that finding if you let it settle slowly. The body, it seems, does not require light specifically. It requires reliability, something steady enough to return to again and again regardless of what form that steadiness happens to take. Researchers studying human connection more directly have noticed something even more delicate sitting beneath this idea, something involving not just shared schedules, but shared physiology itself. Psychologists studying close relationships have found that people who spend extended time together, particularly those sharing a home, a bed, a daily rhythm of presence, often begin to show measurable synchrony in their own biological signals. Heart rates that rise and fall together during quiet conversation. Breathing that gradually settles into matching patterns when two people sit calmly near each other for long enough. Even sleep cycles themselves. Researchers studying couples who have shared a bed for many years have found can grow subtly aligned over time, each partner's body quietly adjusting itself around the steady presence of the other. It seems that closeness itself may function in its own quiet way, as a kind of rhythm giver separate entirely from anything related to sunlight or darkness. Two nervous systems, simply by remaining near each other consistently enough, appear to begin keeping gentle time together. The way two clocks placed near one another on the same shelf will sometimes slowly drift into matching rhythm, purely through the faint vibrations passing quietly between them. This pattern appears even earlier than adulthood in something researchers studying infant development have observed closely. A newborn arrives into the world with almost no functioning circadian rhythm of its own, sleeping and waking, in short, scattered bursts with little relation to actual day or actual night. What gradually teaches that small developing body to settle into a steadier pattern is not only daylight streaming through a window, though that plays its part. It is also evidence suggests the steady presence of a caregiver, the regular rhythm of feeding, of holding of a heartbeat, heard closely and often gently in training a new nervous system, the same way the moon's pull entrains a tide. Connection, present from the very beginning, quietly teaching rhythm before the sun ever fully gets the chance to. There is something deeply moving if you sit with it for a while in realizing that the very first rhythm most of us ever learn may come not from light at all, but from another person's steady, patient presence. It may be worth returning once more to that narrow terminator zone circling our imagined locked planet, the one neither blazing nor frozen, simply existing somewhere in between. If life ever did gather, their biologists wondering about such things have speculated that creatures evolving permanently inside an unchanging dusk, with no daily light cue to organize themselves around at all, might rely far more heavily on signals passed between each other than on anything coming from the sky. Sound, touch. Some chemical signal exchanged quietly between bodies, a rhythm built entirely from connection, because connection, unlike a star fixed motionless in the sky, can still move, still vary, still offer something steady enough to organize a life around even when nothing else in the environment ever changes at all. It seems that wherever light fails to provide a rhythm, something else in nature tends to step quietly into its place. Tides where light cannot reach, geothermal pulses where tides themselves grow faint, and connection perhaps in the more complicated, more tender corners of life capable of forming bonds with one another at all. A pattern repeating itself gently across vastly different scales, from a worm anchored to a deep ocean vent to two people quietly sharing the same bed for 20 years, their breathing slowly falling into the same unhurried pace without either of them ever once deciding to make it happen. There is a particular kind of comfort in this thought, the idea that rhythm itself is less about any single source and more about reliability wherever it can be found. A planet without a sunrise does not necessarily mean a planet without rhythm. It only means the rhythm would have to come from somewhere else patiently, quietly, the way it always seems to find a way to given enough time and enough willingness to listen for it. The mind, it seems, has been keeping something still and patient all along, somewhere beneath the reach of any single sunrise, in a rhythm built less from light and more from everything steady enough to stay close. There is a particular rhythm that lives inside a sleeping body, one that has nothing at all to do with the sun, and almost everything to do with something closer to tide than time. Researchers studying human sleep have found that even after the lights go out, even after the eyes finally close and the mind begins its long, slow descent into rest, the brain does not simply settle into one flat, unmoving state and stay there until morning. It moves instead through a quiet, repeating sequence, rising and falling in distinct stages again and again throughout the entire night, the way water rises and falls along a shoreline governed not by daylight, but by something deeper and steadier. It seems that nearly every 90 minutes, give or take, the sleeping body completes one full cycle. Through this sequence, drifting from light, easily disturbed sleep into something progressively deeper, before rising again toward a stage filled with rapid eye movement and vivid, often half-remembered dreaming. Researchers refer to this entire 90-minute pattern as the sleep cycle, and most adults move through somewhere between 4 and 6 of these cycles in the course of an ordinary night, each one slightly different in shape from the one before it, the way successive waves along a beach are never quite identical, even while following the same essential rhythm. The earliest portion of this cycle carries the body into what scientists call slow-wave sleep, a stage marked by long rolling patterns of brain activity that researchers studying brainwaves have named delta waves, the slowest and deepest rhythm the resting mind produces. Studies indicate that this stage is when the body undertakes much of its physical repair tissue, rebuilding itself, growth hormone releasing in its largest concentrated bursts, the immune system quietly strengthening its defenses for the day ahead. It is in a sense the deepest and most still point along the entire nightly tide, the place furthest from the shore of waking consciousness, where the mind grows nearly impossible to rouse, even by sounds that would easily startle it earlier or later in the night. There is something almost geological in picturing this stage, a kind of bedrock. The rest of sleep is built upon dense and slow and largely silent, doing its essential work far beneath any place where dreams or thoughts could reach it. From this deepest point, the body begins its slow return back toward the surface brain activity, gradually quickening until it arrives at the stage most associated with dreaming. The one researchers named for its most visible feature, the rapid flickering movement of the eyes beneath closed lids. Neuroscientists have observed that brain activity during this stage looks on certain measurements remarkably similar to brain activity during ordinary waking thought. fast, varied, almost busy, even while the rest of the body remains in a state close to paralysis, muscles deliberately disconnected from the mind's instructions so that whatever is being dreamed cannot accidentally be acted out by the sleeping limbs lying still beneath the blankets. It may be that this particular stage rapid eye movement sleep plays a quiet but essential role in how memories are sorted and kept. Researchers studying memory consolidation have found that during this dreaming stage the brain appears to revisit recent experiences, weaving them gently into the larger, older fabric of everything already stored there, strengthening certain connections, softening or releasing others. It is sometimes described in research papers exploring this process almost like a kind of nightly editing, the mind quietly deciding without any conscious involvement at all what from the day deserves to be carried forward and what can simply be allowed to fade. There is something tender in imagining the mind working this carefully on something so personal, sorting through an entire day's worth of small moments with the same unhurried patience a person might use, sorting old photographs, keeping some, gently setting others aside, never rushing the process, never needing anyone to watch it happen. This entire 90-minute rhythm, rising from light sleep into deep, slow wave sleep, and back up into dreaming, was first carefully mapped by an American researcher named Nathaniel Kleitman in the middle of the 20th century, working for years alongside his student Eugene Nasarinsky, the same pairing that first identified rapid eye movement sleep at all, almost by accident, while observing the fluttering eyes of sleeping research subjects late one night in a quiet laboratory. What we understand so far suggests that Kleitman's work revealed something larger than sleep alone. He proposed that this same 90-minute rhythm might continue quietly, even during waking hours, a theory he called the basic rest activity cycle, suggesting that the mind moves through gentle waves of heightened alertness and softer, more drifting attention all day long, whether or not a person ever notices it happening. It is worth sitting with that idea for a moment gently. If Kleitman's theory holds even partially true, it would mean that this same tidal rhythm we associate so closely with nighttime sleep may actually run quietly beneath every single hour of a person's life, day and night alike, rising and falling in 90-minute waves, long before the lights are ever turned off and long after they come back on again the next morning. We tend to think of sleep as something separate from waking life, a different country entirely reached only after crossing some clear and obvious border. But it may be closer to the truth to say that the same tide simply runs quieter during the day, easier to overlook beneath the noise and motion of ordinary hours, surfacing into something we can clearly recognize only once the rest of the world grows still enough to notice it. There is a kind of psychologist term for the smaller version of this rhythm observed even within a single afternoon. Studies indicate that attention and energy naturally rise and fall across the day in cycles lasting roughly 90 minutes to 2 hours periods of sharper focus, followed by a quiet need to drift, to look away, to let the mind rest briefly before gathering itself again. Researchers studying productivity and attention have found that working with this rhythm, rather than constantly fighting against it, tends to leave people steadier and less depleted by the end of the day. It seems that the body has never actually stopped keeping this same tidal rhythm we associate with deep night. It simply continues quietly beneath everything else, whether anyone is paying attention to it or not. This brings us back gently to that long, narrow terminator band circling the locked planet we imagined earlier tonight, the place neither blazing nor frozen, simply existing in permanent, unchanging dusk. If a planet like that has no true day and no true night, no large daily tide of light and dark to organize a creature's life around, perhaps the smaller internal tide we have just described, The 90-minute rhythm rising and falling quietly beneath conscious awareness would matter there more than anywhere else. A rhythm not borrowed from the sky at all, but carried entirely from within the way ours seems to be as well, regardless of how loudly or quietly the sun outside happens to be speaking on any given day. There is something almost reassuring in this thought. Even stripped of every external cue, even removed entirely from sunlight, from seasons, from any large celestial rhythm at all, a mind still seems to find its own smaller, steadier wave to follow. The body, in other words, does not strictly need the world to give it rhythm. It seems to have brought its own rhythm along with it from the very beginning, the way a person humming quietly to themselves does not need music playing nearby in order to keep a beat. There is one more layer to this nightly tide worth resting with for a moment, something researchers have only begun to understand clearly within the last couple of decades. Neuroscientists studying the brain during deep sleep have found that the space surrounding brain cells appears to widen slightly during the deepest stages of slow-wave sleep, allowing fluid to move more freely through tissue that during waking hours sits more densely packed together. Researchers have given this process a quiet, almost poetic name, calling it the glymphatic system, a kind of slow internal cleansing that seems to wash gently through the brain, specifically during the deepest hours of rest, clearing away certain waste products that accumulate steadily throughout a day of ordinary thinking and waking effort. It seems that this cleansing tide, much like the larger 90-minute rhythm surrounding it, requires genuine stillness in order to do its work properly. The same way a river runs clearer once the current settles, and the silt has time to drift quietly down to the bottom, the brain appears to need real uninterrupted depth of sleep before this clearing process can fully take hold. Researchers studying the system have suggested that fragmented or shallow sleep, interrupted again and again before it has the chance to reach its deepest point, may leave at least some of this nightly clearing incomplete, the metaphorical water in the room left just slightly murkier than it could have been. There is something quietly moving in picturing this particular kind of stillness, not as emptiness, not as simply an absence of activity, but as an essential kind of motion in its own right. The deepest, most unmoving hours of sleep are in their own quiet way, some of the most active hours the brain experiences all day, simply working in a register far too slow and far too gentle for conscious awareness to ever directly notice. It may be that this is one of the gentlest truths buried inside the whole long architecture of a single night's rest. So much necessary work, so much quiet repair and clearing and careful sorting of memory depends entirely on a kind of stillness that can sometimes feel from the outside indistinguishable from nothing happening at all. A resting body looks to anyone glancing in from a doorway almost perfectly motionless, and yet beneath that stillness, an entire tide moves steadily through it, rising, falling, clearing, sorting, repeating itself patiently every 90 minutes or so, all night every night, asking nothing of the person experiencing it except the simple willingness to remain still long enough to let it finish its quiet work. There is a particular kind of trust required in that, even if it rarely feels like trust in the moment, a willingness to stop directing things for a while, a willingness to let something slower and older than conscious thought take over the work entirely the way the body has clearly been doing every single night for as long as bodies have existed at all, long before anyone had a name for delta waves or rapid eye movement, or any of the careful science we've wandered through tonight. The slow tides inside a resting mind do not need permission to keep moving. They have been moving steadily all along, quietly, faithfully, the same unhurried rhythm rising and falling beneath every single night a person has ever lived through, including very gently this one. There is a particular threshold most people cross every single night without ever quite noticing the moment it happens. Not the moment eyes close, something gentler slightly later than that, the soft passage between still being aware of the room and no longer being entirely sure where the room ends and a half-formed thought begins. Researchers who study this transition have given it a name almost as quiet as the state itself. They call it hypnagogia, the threshold stage of falling asleep, neither fully wakeful nor fully dreaming, simply suspended somewhere between the two. It seems fitting somehow to arrive at this particular stretch of the night, while still holding gently the image of that locked planet's narrow terminator band, the place neither blazing nor frozen, simply existing in its own permanent in-between. The body, it turns out, carries a version of that same geography inside it every single night, a brief internal dusk that every person passes through, on the way toward deeper rest, whether or not they ever consciously notice having crossed it. Neuroscientists studying brain activity during this stage have found that it carries a particular electrical signature slower and gentler than ordinary waking thought generally falling into a pattern. Researchers call theta activity a quieter rhythm than the brain produces while fully alert and not yet the very slow rolling waves that arrive later during deep sleep itself. It seems that the mind during this stage sits somewhere genuinely between two different modes of operating, not failing to choose one or the other, but resting briefly in the space where both partially overlap. Researchers studying this threshold have found that thought itself behaves strangely here, looser than ordinary waking thought, less concerned with logic or sequence, more willing to let one image drift into another without explanation. A face from years ago might surface beside a half-remembered conversation from earlier that same day, with no clear thread connecting them, and the mind in this particular state rarely seems bothered by the absence of a thread at all. It simply allows the images to pass through one after another the way clouds pass without needing to explain themselves to the sky holding them. There is something worth sitting with in that detail. So much of waking thought insists on sense, on order, on one idea leading reasonably toward the next. This brief nightly threshold seems to ask for none of that. It seems to welcome whatever drifts through without judgment, without insisting that any of it means something in particular. This particular quality of the hypnagogic state has actually drawn quiet attention from people working in creative fields for a very long time, long before any formal research existed to explain why. Historical accounts suggest that the inventor Thomas Edison developed a small deliberate habit around this exact threshold, settling into a chair for a brief rest, while holding metal balls loosely in each hand, positioned above two metal plates resting on the floor beneath him. The moment sleep arrived, deeply enough to loosen his grip entirely, the balls would fall, the sound striking the plates below just enough to wake him gently right at the edge of that threshold, before he ever sank fully into deeper sleep. He is said to have used this brief suspended state quite intentionally, hoping to catch whatever loose, unconnected thought happened to be drifting through his mind in that particular moment. It seems that he was not alone in sensing something valuable in that narrow window. Accounts describe the painter Salvador Dali practicing something remarkably similar, decades later, holding a heavy key loosely over a metal plate while resting in a chair waiting for that same soft threshold to loosen his grip and startle him gently back toward the surface. Researchers studying creativity and attention have since suggested that this particular stage may genuinely allow for looser, more unusual associations between ideas than fully wakeful thought. Typically permits the mind, briefly relieved of its usual insistence on order, free to let distant ideas brush quietly against one another without forcing any immediate explanation. There is something tender almost in picturing two people from very different corners of history, working in entirely different fields, independently discovering the exact same narrow threshold and learning gently how to linger there just a little longer than the body might have chosen on its own. More recent research has approached this same threshold with considerably more precision than a handful of metal balls dropped onto a plate. Researchers at a major research institution conducted a study just a few years ago in which participants were gently woken at varying points as they drifted towards sleep, asked simply to report whatever thoughts or images happened to be passing through their mind in that exact moment. What the researchers found echoed something Edison and Daly seemed to have sensed intuitively decades earlier. Reports gathered from this hypnagogic threshold tended to be unusually loose and associative, blending recent memories with abstract dreamlike imagery in ways that fully waking thought rarely produces on its own. It seems that this brief nightly passage genuinely does offer the mind something different from either full wakefulness or full sleep, a kind of soft, unguarded space where ideas are permitted to wander without needing anywhere particular to go. It may be that there is something quietly meaningful in simply allowing this threshold to exist undisturbed, rather than rushing through it or resisting it, or trying to hold on to wakeful thought a little longer than the body's asking for. So much of ordinary daily life trains a mind toward the opposite habit entirely, toward staying alert, toward holding focus, toward resisting precisely this kind of soft, directionless drifting. And yet here, every single night, the body offers this same threshold, freely, gently asking nothing more than permission to let it happen. There is a particular kind of unsettled sensation some people experience right at this threshold, a sudden brief muscular twitch, often accompanied by the unmistakable feeling of falling, even while lying perfectly still and safe in bed. Researchers studying this phenomenon refer to it as a hypnic jerk, and while a fully settled scientific explanation remains gently out of reach, some researchers have proposed that it may relate to the body's relaxing muscles, being misread briefly by certain ancient neural pathways as an actual loss of balance, prompting one small reflexive correction before sleep continues on its way. It is a strange, almost endearing detail if you sit with it for a moment. Some quiet old part of the body still keeping watch, even at the very edge of sleep, simply making sure that everything is still safe before finally allowing itself to let go completely. It seems that this entire threshold twitch included asks for a particular kind of trust that can be difficult to offer at first, a willingness to stop tracking exactly where a thought came from or where it might be going, a willingness to let the mind soften its grip on coherence, the same soft release Edison and Daly once waited so patiently to catch hold of, except here tonight there is no need to catch anything at all. No metal ball waiting to startle you back to the surface. Only the threshold itself open and unguarded, free to be crossed however slowly it needs to be crossed. This brings us back gently once more to that narrow band of permanent dusk circling the locked world we have spent this entire evening imagining together. We spoke earlier of how that terminator zone might be the only place on such a planet where conditions ever settle into balance, neither burned by endless light nor buried by endless cold, simply resting in its own quiet, unchanging middle. It may be that this same pattern, life and meaning gathering, not at the extremes but somewhere in the soft overlap between them, holds true even here, even now, in the quiet space between a fully wakeful mind and a fully sleeping one. Not the sharp clarity of full attention, not the complete release of deep, dreamless rest. Something gentler than both existing comfortably in its own narrow twilight register, asking nothing more than to be allowed to pass through undisturbed, There is a kind of meaning that seems to arrive most easily in exactly this register, the soft, unfocused space neither fully thinking nor fully resting. Psychologists studying reflection and insight have noted that some of the clearest emotional understanding people experience does not usually arrive during moments of sharp, deliberate analysis, sitting upright at a desk attempting to reason something out directly. It tends to arrive instead in looser, quieter moments, somewhere closer to this exact threshold, where the mind has finally stopped gripping a problem tightly enough to let a softer kind of understanding settle in on its own. It may be that meaning, much like rest, much like the narrow habitable band circling a locked and distant world, simply prefers the in-between. Not the loud certainty of full wakefulness, insisting on answers demanding resolution. Not the complete absence of thought that comes later once sleep has fully arrived, and there is nothing left to settle at all. Something quieter than both. A soft seam where understanding does not need to be reached for because it has already gently arrived on its own. There is nothing left to figure out in this particular stretch of the night. Nothing waiting to be solved or completed or carried forward into tomorrow's clearer light. Only this narrow, familiar threshold, the same one a body has crossed every single night of its life, long before any researcher gave it a name, long before anyone thought to study what passes through a mind exactly here, in this soft and unguarded space between thinking and rest. It is perhaps the gentlest kind of geography a person ever gets to visit. Not a place on any map, not a planet circling some distant dim star, just this. A quiet seam inside a single resting body settling now, the way it always eventually does, into something even softer still. The threshold we just crossed together does not stay open for very long. It rarely needs to. Researchers studying the earliest minutes of sleep have found that once the mind allows itself to drift past that soft in-between stage, something quieter begins almost immediately afterward. A gradual closing of the senses one by one, the way someone might walk slowly through a house at night, turning off each lamp in turn, leaving the rooms behind in soft, deepening dark. It seems that the brain does not switch off all at once. Sound is often one of the last senses to fade, which is part of why a familiar voice can sometimes still reach someone in those final minutes before sleep, even after sight and ordinary thought have already begun to loosen their hold. Neuroscientists studying this transition have observed a structure deep within the brain called the thalamus, which spends ordinary waking hours acting almost like a relay station, passing sensory information steadily onward to the rest of the brain. As sleep approaches, this small structure gradually quiets its own activity, gently reducing how much of the outside world gets passed along at all. Not closing the door suddenly, simply easing it shut a little more with every passing minute. There is something tender in picturing this quiet internal narrowing. The world does not disappear all at once. It simply grows softer, dimmer, less insistent, the way a sound heard from another room grows fainter, the further someone walks from it, never silenced abruptly, just steadily left a little further behind. It may be that this is one of the last small things worth noticing tonight before we let the rest of this evening's long, slow wandering settle into stillness. We began this night standing in a sense on the surface of a planet that never sees a sunrise, a place locked permanently between blazing light and endless dark, with only that narrow twilight seam offering anything resembling balance. Astronomers studying the stars capable of holding worlds like this in such close locked orbits have found something quietly remarkable about them as well. The small dim reddish stars most likely to create these locked sunless worlds also happen to be among the longest living stars in the entire universe, some expected to keep burning gently, steadily for far longer than our own sun ever will, stretching out across spans of time, too vast for a human mind to hold on to with any real precision. It seems that a planet without a sunrise might also be in its own strange way one of the most enduring kinds of places the universe knows how to make. No violent changes pulling it apart, no dramatic shifts in season or light, just one long unbroken stretch of sameness, held steady by a star patient enough to keep burning quietly for trillions of years, far past the point where brighter, more dramatic stars will have already faded into darkness themselves. There is something quietly comforting in that thought if you let it rest there for a moment. The places built from the least change are sometimes the ones built to last the longest. We are not going to travel back out to that planet again tonight. There is no need. It will still be there exactly as it was unmoving, patient holding its same locked position beneath the same unmoving star whether or not anyone is awake to imagine it. That is in its own way part of what makes it gentle to think about. It asks nothing of us. It simply continues quietly, the way certain things in this universe always have, long before we arrive to wonder about them, and long after we have stopped. The body resting now wherever you're listening from is doing something quietly similar in its own much smaller way, settling slowly into its own steadier rhythm, letting the thalamus close its small soft door a little further, letting the muscles loosen one by one the way the grip around Edison's metal balls must have loosened all those years ago somewhere near this exact same threshold. There is nothing left to explain tonight, nothing left to figure out or carry forward or hold on to too tightly. Only this, a quiet body in a quiet room slowly letting go of the small effort it takes to stay awake. The thoughts may still be moving a little here and there. That is all right. They do not need to stop completely. They only need to grow a little softer, a little slower, like footsteps fading down a long hallway. Somewhere outside the night is simply continuing the way it always does without needing anyone to watch it. A sky settled into its own stillness. Stars that have already been burning quietly for longer than anyone could ever count. There is no sunrise waiting just yet, only the dark holding gently the way it has always known how. Breath in and slowly out. The room grows a little dimmer now, not because anything is fading, just because it is allowed to. A pillow, a quiet weight settling into it. Somewhere far off, a planet keeps its same still face turned toward its star patient unmoving, asking nothing of the dark beside it. And here in this small warm room something very similar is happening. Nothing more to notice, nothing more to hold. Just this soft settling dark, and the quiet steady place beneath it where everything finally rests.